Okay, here we go. It's our first lesson. Today we're going to talk about square roots. Now this is from the section 7.1, page 290. So you may or may not have your books at home. If you don't have your book at home, remember you can log on to bigideasmath.com. Okay? That's where you'll see all the examples and stuff I'm going to go through, but I'll make sure I write everything down. All right, so if you have your book, have it open at page 290, or if you have a second device, that would work also. Square roots. So first of all, our definition of square roots is this. Square roots. A number that, when multiplied by itself will equal the given value. Okay, and that can be positive or negative. So, for example, I might say the square root of 9 is 3, because 3 times 3 equals 9. Or the square root of 100 is 10, because 10 times 10 equals 100. Okay, so that's our first vocab word. Then we've got something called perfect squares. Perfect squares are when the square root comes out as a whole number. And once again, that can be positive or negative. Now, square roots can be decimals, or if they don't come out as a perfect square, like they don't come out as a whole number, then you can estimate that they fall in between two different numbers. Okay? So let's look at example 1. So example 1 from the book talks about how square roots, actually there's 2 of them. So you actually have 2 square roots, because one is positive and one is negative. So, for example, 7 times 7 equals 49, right? Also, negative 7 times negative 7 equals 49, because remember, a negative times a negative equals a positive. So, if I wanted to say the square root of 49, that's that little symbol. We'll write that down next. But that little symbol is square root symbol, and it looks like a division with a little tail on it. So the square root of 49 actually has 2 answers. It has 7 and negative 7. Because 7 times 7 would give me 49, and negative 7 times negative 7 would give me 49. So this is what our symbol looks like. It's kind of like a division sign. It's got this little tail on it. So we'll call this our symbol. It's called a radical sign. Radical sign. Okay. And inside the symbol is where you put your number that you're looking to find the square root of. So that number is called the radicand. Number is called radicand. Okay? so let's do a couple examples. We'll do a positive and negative and then a both. So positive, oops, spelled that wrong. A positive example might be a square root of 16 is 4, because 4 times 4 is 16. A negative would look like this. We'd have a negative sign in front of the square root. So the negative version of square root of 16 would be negative 4. And once in a while, we don't do a whole lot of this in our class, but when you get to like Algebra 1 and 2, you'll have both, and it will look like this. You'll have a new symbol, which has both adding and subtracting, and then your radical sign. So positive negative is what they call that. So positive negative square root of 16 is positive negative 4. So then you're getting two answers because you have a positive and you have a negative. Okay? All right, now remember, as you're watching the video, you can always pause or rewind or, screenshot if you want to jot these notes down later. Okay, next, example 2 in the book. Okay, so they're going to give us an A, a B, and a C. A looks like this. B looks like this. And C looks like this. Okay, so we've got 3 different kinds of problems here. This first one is just a positive. All right. So if that's a positive, the positive square root of 25 is 5. So we would say that's our final answer. Now, when you've got a fraction, you're going to treat it like 2 different fractions, just like when we had exponents. So you're going to do, not 2 different fractions, 2 different square roots. So you're going to do the square root of 9 and you're going to do the square root of 16 as 2 separate things, okay? So first of all, this is a negative. So let's take the square root of 9 first. We know our answer is going to be negative. The square root of 9 is 3. And then the denominator has a 16, so the square root of 16 is 4. So negative 3/4 is our answer. Okay. And the last one is both. This one has that plus minus, so it's both positive and negative. So we're going to do the plus minus again. Now this is a decimal, so you'll have to use a calculator for this one. Now I assume most of you are going to use your phone calculators. Remember, if you turn it sideways, you'll get a square root symbol. And it's going to be different depending on which calculator you have, but here's the square root symbol on mine. Actually, this is my son's because my phone is doing the recording. So we're going to just type in square root symbol first, then 2.25 equals 1.5. So positive negative 1.5 would be our answer there. Okay? Did everybody see that square root symbol? So that's how you can do that on your calculator. Okay? Remember, it's just a regular calculator, and then when you turn your phone sideways is how you get those extra symbols. Okay, it doesn't want to do it, but you guys got the idea. Okay? All right, so let's do some Oreos. Now, I know you guys don't have your book, or a lot of you, so I'm going to write them out for you. There's 6. So number 1 to 6. 1, 2, 3, 4, 5, 6. Okay, 36. And I want you to give me the 2 possibles, okay? Unless they specify. So like the first 3 should have 2 answers because there's nothing specified. I just want the square roots. Find 2 square roots. Okay. These I'm going to specify if I want it positive or negative. So negative square root of 1 plus or minus square root of 4 over 25. And this one is positive square root of 12.25. Okay, go ahead and work on that for a minute. You'll need your calculator for number 6. Okay, if you're not done yet, that's okay. Go ahead and follow along. Now, I don't have my cards to call on people, unfortunately, so I'm just going to have to go through these, and if you get one wrong, fix it, okay? So the 2 square roots of 36 should be 6 and negative 6, because both of them, when multiplied by itself, equal 36. The 2 square roots of 100 should be 10 and negative 10, because again, when you take both of these numbers and multiply them by themselves, they equal 100. And the 2 square roots of 121 will be 11 and negative 11. Okay, so now we're going to move over here where they've given us specific ways that they want our answer. So this one is the negative version, so we know our answer is going to be negative. The square root of 1 is kind of an unusual number. It's just 1, because 1 times 1 is 1. So that's one that's actually itself. Number 5 is a fraction, so remember you treat that like 2 separate square roots. And we've got this plus minus symbol here, so that's going to be in our answer, plus minus. The square root of 4 is 2, so that's our numerator. Square root of 25 is 5, so that's the denominator. And number 6, you have to use the calculator on. We know it's going to be positive. Let's see here. Let me find Trevor's calculator. Here we go. All right, let me see if I can get this to work this time. There we go. So square root 12.25 equals 3.5. And it's a positive. Okay? All right, so that's basically the gist of square roots. Remember, I said sometimes you will be estimating, and some of the worksheets will give you some more examples of that, but you would estimate where it would fall in between. So let's just do one here so you'll know. Let's say I say estimate the square root of 21. Well, if you do it on your calculator, clear, square root of 21, you get 4.58. So we would estimate it, let's say this is an estimation of maybe 4.5. Okay, so you would say that it's between 4 and 5. And that makes sense because 4 squared is 16, 5 squared is 25, and 21 falls right in between. Okay, so when you estimate, you can use your calculator, and then you'll know which 2 consecutive whole numbers it falls in between. Consecutive whole numbers just means 2 numbers in a row. So you can estimate between those 2. Okay, next, let's talk about one more thing that we need to address with square roots, and that's what example 3 is going to get to. So example 3 talks about evaluating like our order of operations with square roots, because the square roots will be the same basically as exponents. It's just kind of the opposite of squaring. So when you evaluate with a square root, okay, so that's what we're going to talk about here, evaluating with square roots. So evaluate, remember, means to get the answer to a problem. So these will be some of those long problems that have order of operations. What we want to say is this: square roots go with exponents. Did I spell it right? Exponents? Yes. In PEMDAS. Remember our please excuse my dear Aunt Sally, right? Because it's the inverse of squaring. Okay? So, in example 3, part A looks like this. Write this problem down. 5 square root 36 plus 7. Okay, everybody write that down. All right, now one thing you're going to notice is when you have a number next to a square root sign like this, it's similar to a parenthesis. That means multiply. Okay, so this 5 stays in the front, times. So we don't have any parentheses here, so that's our P. Next would be exponents, so that's our square root symbol, because remember, it's the inverse of squaring. So the square root of 36 is 6, and then plus 7. Okay, now following our order of operations, 5 times 6 is 30, plus 7, so we have 37. Okay? Let's look at example B. Okay, example B looks like this. 1/4 plus square root of 18 over 2. All right, so now let's simplify this a little bit because 18 over 2 looks like a fraction, but neither one of those are perfect squares. So I can instead divide that because 18 divided by 2 is 9, and 9 is a perfect square. So I'll have 1/4 the plus square root of 9 because 18 divided by 2 is 9. Now I can do square root of 9. So 1/4 plus the square root of 9 is 3. So the final answer is just 3 1/4. Okay? Now, C gets into something that's a little bit tricky, but write this down. So C looks like this, a parenthesis, then a square root of 81, and then close parenthesis, then exponent of 2 minus 5. Now here is something that's unusual, and you'll see it once in a while, but when you square something, that's this little 2, and you square root it, they kind of cancel each other out. Okay, because if I take the square root of 81 is 9, and then I square it, 9 times 9 is 81. So it gets you right back to 81. Okay, so squaring and then rooting, let's call it rooting, square rooting, cancel each other out. Each other out. Okay, so this whole thing is just 81. So now I've got 81 minus 5, which equals 76. Okay, all right, I'm going to have you do one of the Oyos. Hang on, let me grab another piece of paper here. Let's do, all right, Oyos. We're going to do Oyos. Let's see, I said just one, so let me pick a good one here. Let's do Oyo number 8. Square root of 28 over 7 plus 2.4. All right, well, 28 and 7 are not perfect squares. They don't have a square root, so let's divide them instead. So 28 divided by 7 would be 4. So now I've got square root of 4 plus 2.4. Square root of 4 is 2 plus 2.4. So 2 plus 2.4 is 4.4. Okay? All right, I do want you to try one more. This one do on your own. Number 7. I'll write it out for you and give you time. 12 minus 3 square root 25. Let's see if you remember what that means. Okay, so go ahead, everybody try that one. Okay, so remember this means multiply, right? So following our order of operations, first thing I'm going to do is parentheses. There are no parentheses, so we move into exponents, so that's this. So square root of 25 is 5. Everything in front of that stays the same. So now following my order of operations, this comes next. 3 times 5 is 15. So 12 minus 5, the answer is -3. Okay, and that's it. So let's talk about what's going to happen this week. So I've got our planner sheet here. Now, some of you remember our Monday, some of you are Tuesday, depending on which hour you are, but it's the same for every week. I forgot to bring my finger pointer home. I'm kind of disappointed in that. I'll have to get it next time I go. But anyway, I'll use this marker as a pointer. So here are some things you need to do this week. Question on the meeting from last Thursday. So far, I think I have 24 people that answered that question. But if you attended the meeting last week, go on to my Google Classroom and answer the question about anything you can remember. That will give you participation points. Then you'll notice that there are some choices for square roots on the Google Classroom. So answer the question about which assignment you chose to do on the square roots. That will give you a participation point. And number 3, attend the live meeting this week on April 30th. It's Thursday again. Or if you can't make the live meetings, I know some of you guys are, sharing tablets and computers and Chromebooks with your siblings or your family members. It's not a big deal, okay? If you can't make the live meeting, it's just a check-in. Just email me and tell me you can't make it, and I'll consider that as attending the meeting, and you'll get your participation point. Okay? So after you attend the meeting, you answer the question about the meeting, or you send me an email. So whether you're a Monday or a Tuesday, depending on which hour you are, they're all the same. Again, Thursday this week, we have our live meetings. So 2 o'clock will be hours 1, 5, and 6. 2:30 is hours 3 and 4. I'll post those links on Wednesday night in the Google Classroom, and you can come to the meeting on Thursday. Okay? All right, have a good week. See you guys later.